I'm excited. This is my opportunity to get to know you.
Okay.
Here, let me cuddle up here. There we go. So, yesterday I mentioned to you a couple of the topics of the chat, and you looked at me like, what is this? So I went back through, I watched a couple keynotes that you did, and I corrected myself a little.
All right.
I hope that this suffices. Can you maybe give like a longer intro about who you are to you, or who is Limor for
Okay.
Limor?
So I'm running a startup now called MOV.AI that is developing software for robots. It's based on an open source called ROS. ROS is the only pretty much software now that survived during the last 10 years as a framework for developing modern automation. And ROS is there's a very active community, thousands of contributors. But ROS was really invented for academic experimentation. So if you want to do a self-driving car, you know, with ROS you can probably do it in a few days. But if you want to make a road-safe self-driving car, then you have to put in a team of 50 people in a couple of years. Same thing with logistics robots. There's a proliferation of logistics robots. There's probably 150 companies that do autonomous robots that drive around in factories and in warehouses, and the thing is that it's very easy to get through a prototype. So if you've got a mechanical system, electromechanical system, you want to give it some software, some AI, it's quite straightforward. But going from there to a reliable system that works around the clock, dealing with the faults of the mechanisms, dealing with battery recharge or different scenarios of automation, either following people, avoiding people, getting autonomously from point to point, or following a very clear trajectory. So all these things are more the practical sides of doing robotics and automation. Then that ROS was not really conceived for that. So we take ROS and give it another layer of robustness and all the missing features like fleet management, cybersecurity, scripting, or dealing with the system integrators that need a different set of tools. Then they cannot just go there and program in C++. So that's what MOV.AI does.
Okay, and that's kind of the foundation, I guess, of why you call it the Android for robotics.
Yeah, because we needed some kind of analogy to say what we do. Android is so the operating system is still Linux, right? But you've got this framework that gives you touchscreen apps, security, system configuration, financial ecosystem. So we want to do the same thing, but in a different kind of hardware environment. So it's close enough. First we called it Red Hat, but then Red Hat was not very clear how far the analogy goes. Android is a bit closer, even though, yeah, it's...
So it's really interesting technology, I think, but what's the point for you, personally? Why bother doing this thing? I mean, as a smart guy who can work in a complex field like this, there's a lot of things you could do. So what connects you to the mission, or what is the mission of MOV.AI, really?
So I've been doing robotics. Previously I had a company in telecommunication software. That was it was a Silicon Valley company. We raised tons of money, and we sold it in 2003. And it was a software company that was helping billing systems in the internet. So there was the big bad internet coming in the 90s. And especially mobile operators didn't really know how they're going to monetize on it. They knew this is going to cost them a lot of money. At the time, there was GPRS and all these frequencies that they needed to buy, and it wasn't clear how they're going to make money out of it. So we did this software that was allowed them to monetize the internet. And the company was doing pretty well, and unfortunately, Bin Laden spoiled our IPO. And so, but the company was sold, and after that, I always wanted to play with robots, and so I decided to take some time off and go back a bit to university and learn about automation, about control and robotics, and that was 2004, 2006, and then I set up a company that started selling robot components in order to try and get enough revenue to drive R&D, because I couldn't raise funding for. I wanted to do these violent robots that fight each other, like a video game, little humanoid robots.
Cool.
If you remember Star Wars, Return of the Jedi, they are in the Falcon, Millennium Falcon, and they're really bored on the spaceship, and they have this little chessboard with holographic robot. That's what I wanted to do. So I had a beautiful business plan for that, and I went to VCs to try to get money, and I remember in Excel Partners they told me, we don't do flying cars, time machines, and robots. Okay. So times have changed. They do all three of them today.
Including time machines.
Yeah, I mean, quantum computing, yeah. And then, so that was, so I try to create enough revenue in the company to justify an R&D lab that will eventually allow for running robots. And after doing that for 10 years, I also realized that the technology is still not there. Boston Dynamics are able to do it, to do these kinds of visual effects, because they spent an infinite amount of money in creating their own hydraulic actuators, and now because of the drone industry, there's all these super powerful magnets that allow for more torque in the joints, and so there are Chinese clones of Boston Dynamics, but it's still really not there, the running humanoid robots at a consumer level. So
what about fighting them?
The fighting, there are Japanese, these Japanese weekend wars. So people bring their own humanoid robots and they fight off. But they're made of servos and they're a bit clunky, and it's more like the visuals are not there. I mean, the world is all about visuals. It's all about, it's the video that gets you the money. And so these humanoid robots were super cool in 2005, 2006. I had a forum, an online forum. I don't know if you're too young to remember that.
I remember the forum days.
Forum days, right. So we had this most popular forum online for robotics and humanoid robot builders, and it was a lot of fun. But that technology with the servos was not, basically ended. Mm-hmm. Nothing has changed, nothing has evolved. That's the key thing, I think, in technology, is if you don't have a evolution in a technology, it dies. This was happened to 3D printers, basically. It was eaten by the Chinese. And servos, the same thing, was eventually died off because there was no evolution. So the problem with robotics is really that for having robots that run around, like we see in science fiction, the main issue is the actuators. It's because biologically, we have a very efficient mechanism of hydraulics. It's very lightweight and viscous, and blood, and then we've got muscles that so we can do very high power, high speed, high precision. This combination you cannot do with electromagnetic motors. No, nobody's cracked that. Because if you want a lot of torque, you have to add a lot of metal. And you add metal, you add weight, you need more torque. It's a vicious cycle. Hydraulics solve that, but there are no microhydraulics actuators that can work and do these tricks. So the technology is not yet there for running robots. But that was the objective over the years. So I created the lab, and we did all kinds of projects with self-balancing robots and humanoid robots, and did cool projects. And then what happened, and here finally I'm coming to your question, about 4 years ago, we were working with Ross, of course, with open source on all these projects. And then I realized that really everybody's tackling the same issue of when going from prototype to commercialization, that Ross was not really well suited for that. And so I raised some angel money
3 million, I think.
No, it was 500,000 first in 2016, and then recently 3 million.
Yeah, just last month or something.
In the summer. Yeah, as a seed funding from Silicon Valley in Israel. The company is in Portugal. The R&D is in Portugal. And so we're building primarily software, but we're using a couple of hardware platforms. One is a robot that pulls carts. So it's fleets of robots that pull carts in factories and postal. So cart business, I discovered, is massive.
Really?
Yeah, I mean, you see them everywhere, but you ignore their existence, a bit like the homeless people in San Francisco. So you just ignore their existence, but they're everywhere. I met a guy who sold to Royal Mail 500,000 carts, metal carts. They're being pushed on a daily basis. So there are people pushing 500,000 carts in Royal Mail.
Wow.
So
can you build 500,000 robots to do that for them?
No, you don't need that many robots, but you can definitely replace people, directly replace people in pushing carts. So that's our sandbox environment for the software. And then another one is a pallet mover. So pallets also, there's 2 million analog, let's call them pallets, the ones you see all around, that you pump and you pull.
Yeah.
So 2 million of these are sold a year. The ones with batteries is, 100,000, and big forklifts you've got as well. And so it's a whole world. It's called material handling. It's a world completely agnostic to Silicon Valley. They do business cards there. They have websites that look like it's 1995. And it's a $60 billion market or something. It's huge. The automation, material handling, and it's huge. But they're not. So Silicon Valley is completely. It's trying to get there and trying to be meaningful in that environment. But they're not. There is no cloud in industry.
Yeah.
You walk around in a factory and you see Windows 98. So it's a very different world, and so I think there is a lot of room there for bringing innovation. So they don't need those robots. So the thing is that the automation is traditional automation, which has been around for 35 years. So robotic arms and conveyor belts and these kind of robots like Amazon that just move along lines. And those have been around 35 years, and they are just designed to last. I've seen in Deutsche Post, a conveyor belt system of 3 kilometers inside a building that has been running 24 hours for 25 years from Siemens. So that was kind of the state of mind. Just to understand the cycle of innovation in Volkswagen, they decommission a robotic arm after 10 years, whether they need to or not. So, and the reason they told me was that in order to allow for innovation to come in. Right? Yeah. So it's a completely different mindset.
Yeah.
Car industry, aerospace, food industry. It's just about repetitive tasks for 25 years. Whereas the new robotics that are coming in now are designed to be cheap and to work with people, and if they last for 2 years, you're lucky. So it's a completely different mindset. And so these new robots, there's 150 companies that are doing mobile robots, another 60, 70 companies that are doing robotic arms of these new generation that are not designed to last, but they're designed to be much smarter and to be much cheaper. And so it's a new kind of market. It's no longer, so Volkswagen are not going to buy these $15,000 robots. They don't, it's not for them. They don't care about that. They will spend 150,000, but it will last for 10 years. And it will work around the clock. And because for them to stop production, it costs millions. So they don't care to spare money. They just want to make sure that it works. Whereas when you are, let's say, here in this convention center or whatever, you've got all these chairs have been set up by people. The food has been transported by people. And so you can automate all that with low-cost robots. And that's where it will end up within a few years. So it means that the market scope is not 100,000 robots a year for the car industry, but it's millions of robots a year
for everybody.
For everybody, for retail. And there was a Kickstarter campaign for a proper robotic arm. for $6,000, a Chinese company. So it's down to that level, which means that it's affordable to the degree that you can just buy, play with it, and see how it goes. The cool factor will be the first thing that will sell these things. People will find a reason to use a robotic arm because it's cool, and it's $6,000. And then, but unlike other technologies, I really think that there are real use cases. So, for example, I've experienced 3D printers. So my other company was the first to sell 3D printers in Europe, the new age, the desktop 3D printers. So we rode this huge wave and this huge promise. Obama was talking about MakerBot 3D printing, and they were sold for 400 million. And we are going to manufacture if the handle on the fridge breaks, we're going to make it with a 3D printer. We're going to 3D print food, and it's all going to be so amazing. Boom, dead. It's because there was no continuation. There was no cycle of innovation.
Yeah.
There was a lot of promise, but when the promise was not fulfilled, it was over. Same thing happened with, for example, telepresence robots. So telepresence robots were a huge promise about 5 years ago, and double robotics, and it was so cool, and everybody was buying it because it was cool. But the usefulness of it was very debatable, because you do your conference call on the mobile, and it's good enough, and you don't need the telepresence robot, really.
Speaking on the cost reduction, like you mentioned, that now there's a Kickstarter campaign for a 6,000 euro robotic arm. You once said in a keynote, and I'm not sure how long ago it was, but you said that at the point where the tipping point would happen at the $5,000 mark,
right,
and that at that point people would have robotic arms washing their dishes and mowing their grass and doing whatever things.
Yeah.
So I'm curious how far away you think that moment is now. If we're getting so close to what you said was the tipping point, I'm just curious, is that still how you imagine the future, and how far away is that future?
No, I think if this Chinese company can scale their operation and sell this collaborative robot arm for $6,000, then we probably are hitting that kind of point where at first it becomes a gimmick. So I will buy it because it's cool. I'll put it in my office.
It's a robot arm,
and then mount it on a mobile platform and go and fetch the beer, and it's still. But then it can do actually useful things like move things around. I mean, we don't really shift around in offices. There is no more post, and there is a little bit of stuff that comes from Amazon, but that's outdoor and not retail. But I think in retail, sort of at home, the usefulness at first will be debatable, will be more of a gimmick thing. But it's inevitable that it will become more of a useful tool because it's been around and the use cases are huge. The use cases for the robotic arms exist already. There's dozens of use cases. And same thing with the logistics mobile platform. There's a million uses for it. So even taking the existing, if we take, for example, just warehouses. In America, there's 500,000 registered warehouses, right? And there's 2 million pallet jacks a year are sold. So if you take that as just the opportunity, that's already a market for hundreds of thousands of units of doing things. And Universal Robot now are spending a lot of money on marketing these use cases for the robotic arm. They got a lot of money, and so they're using it for marketing, and they're leveraging the opportunity for all the other collaborative robot arms, such as the Chinese X-arm for $6,000, in depicting the use cases in the video. What I believe is that it's all about the video. And so if you sell the correct kind of use case through the video, you can create a moment of proliferation of these things. And unlike the telepresence, unlike the 3D printer, I think there is real opportunity here because it's a technology that has already a lot of use cases. So the answer is we're getting there. It will not be necessarily first at home. It will be more of the robotic arm will be in workshops and small production, woodworking, private workshops, and man cave type thing.
To fetch the beer, yeah?
Yeah.
Did you buy yourself a robotic arm to fetch you beer?
To fetch a beer, I don't drink beer, but I'm about to.
Yeah?
Yeah.
Are you going to buy one from the Kickstarter campaign, or?
I'll wait. I don't know if I'll buy from them, but I'm
Yeah.
going to buy a Chinese. The plan is now to buy one. Yeah.
What will you use it for, out of curiosity?
Well, the combination, because we need to test combinations of moving stuff around plus lifting and what's called depalletizing, or moving things from production line to the robot, to the mobile robot and back.
Huh. Interesting. So yours is, you're not going to buy a hobby robot for yourself?
No,
or a
I've had those
hobby
for,
robot arm,
I mean, I've had every generation of hobby level stuff. But this would be the first time that I have like a proper, what's called industrial. The difference is in the gear reduction. That's it.
Yeah.
There is what's called harmonic gear reduction. That's the magic spice of a robot arm.
Okay, the magic spice is...
Yes, that's it. It's called harmonic gear reduction.
Huh, you learn something new every day.
So instead of having 6 gears that reduce the fast-moving motor to a slow, forceful torque, you have one, and it's called Harmonic. Was invented, I don't know, 40 years ago.
Okay.
And the patent expired, but now there's only like 4 or 5 manufacturers on the planet that do this thing. Huh. It's a currency today, Harmonic gear. You have to wait almost 6 months, and you have to a minimum order of a few hundred.
Huh.
It's just very complicated to make.
Okay.
And and if you don't do it properly, they break easily, and there is such high demand. So just for numbers, in China deployed over 200,000 robotic arms in the last year. Each one has maybe 6 or 7 harmonic gears. So we're looking at 1 million harmonic gears. These things are produced manually. There is a manual labor involved in harmonic gears, and there is like one German, Austrian company that is making them, and they have a capacity, a certain capacity. There's a Japanese one, and then there are Chinese ones. And the difference is primarily in the materials. In secret, they have secret materials, because these things need to last for continuous use for 10 years. So if you there was actually a small company that made plastic, industrial plastic harmonic gear, and they were acquired by the German Harmonic Gear AG and shelved. They don't want. It's like Visa and MasterCard. They buy technologies of fintech and shelf them.
Okay. Harmonic gears. You learn something new every day. I want to take a chance to, if there's one of you guys that have a question, then I would love to hear it, or even somebody at the top. Does anybody have a question for Limor? And if not, then I would ask you if there's anything you wanted to. Do you want to teach me anything else about harmonic gears, or is there anything you really hoped I would ask you? What's your secret spice, Limor?
No, my secret spice. What kind of question? I think. I tell you what, I grew up, in my generation, there were these Japanese cartoons where the superheroes were robots.
Huh.
So they were big humanoid robots. And I think that has influenced also in the Japanese culture a lot. So the senior management in the big companies have grown up with these superhero robots, and they want to make them happen. That's why Japanese were obsessed with humanoid robots. And so I guess that's one driver, is like to create these superhero humanoid robots. But otherwise, I think it's just an opportunity. It's like I like the fact that there is this huge market of automation that is living in a different life cycle of innovation. I've seen it happening before with in the telecommunication business, and before that with cybersecurity. And it's just an opportunity, an interesting way of having a big impact.
All right. Well, on that note, thank you so much for joining me, man. It's really interesting to talk to you, actually. I'm sure that you could teach me more today than I could teach you in a lifetime. But thank you, audience. And thank you, Limor.
All right. Thank
Yeah.
you.